Air Force Small Business Innovation Research, SBIR program has supported the development of many mission-critical technologies, including this one for the Air Force's Arnold Engineering Development Complex, AEDC. The ability to unleash devastating weapons from current and next-generation aircraft requires a painstaking process known as weapon certification. To improve the computer modeling and wind tunnel tools used in the certification process, Lockheed and AEDC needed a higher-performing version of pressure-sensitive paint, known as PSP, to measure the rapidly changing aerodynamic effects that can lead to an unstable weapon release. They turned to the small business sector for help in finding a solution.
Our expertise is really in developing measurement technology. Pressure-sensitive paint is just an optical pressure sensor, a compound that you spray on the surface just like you would regular spray paint. You light it up with an LED of the appropriate wavelength, and then you image it with a camera. We use the images from the camera and we turn every pixel on the camera into a pressure tap.
In 2009 and 2010, ISSI received SBIR contracts to transition PSP into a new innovative measurement technology, fast-responding PSP.
The fast-responding pressure-sensitive paints, the polymer is modified so that the oxygen or the air can move very rapidly through the surface. It's kind of the difference between a solid block of concrete and a sponge. And so that allows the paint to respond to pressure changes very quickly.
To take full advantage of fast-responding PSP, better camera and lighting solutions to record the data were needed.
Fast camera technology is far superior to what it was 10 years ago. LEDs are hundreds to thousands of times brighter than they were 10 years ago. And so all of these supporting technologies combined with the fast pressure-sensitive paint is really what allowed the system to come together. The funding that we received from the Air Force and the collaboration with the AEDC team has really allowed us to develop these pieces of the technology.
So what you're looking at here is a scaled down version of a wind tunnel like you'd see at AEDC. Right now you see a small wing with fast PSP on it, and we're looking at the surface pressure distribution across the wing.
Rather than having hundreds, literally hundreds of microscopic pressure gauges on a vehicle, we can have maybe a dozen, and then we can augment the reading of those dozen sensors with this pressure-sensitive paint.
You can see that the PSP actually gets brighter as the local oxygen concentration is displaced by the inert gas. In a high pressure zone, you would have just the opposite effect.
The cost of running a wind tunnel test is quite extensive. Any measurement technology that gets you more data, faster, cheaper, more accurate is a big advantage. So fast PSP, it really fits into that niche.
These wind tunnels are some of the largest in the world and provide our customers with the capability to test aircraft before they actually go to flight. Well, the fast PSP is going to again provide us with a new capability that has not been possible in the past in our production wind tunnels, where we would normally have maybe a few hundred or a couple of hundred point source measurements of fluctuating pressure. Now we can get the equivalent of up to 500,000 fluctuating pressures. This new fast PSP is going to be a game changer and enabling us to provide a significant amount of more information to our test customers.
The SBIR program has definitely supported AEDC's mission in allowing us to be able to develop new test technologies that keep us ahead of our adversaries.
Because of the funding that we got for this particular program to transition this technology into the large-scale production wind tunnel, this accelerated the deployment process by 5 years. For the Air Force, they've invested money in developing this technology and they really want to see it end up in user platforms. And there's a kind of a death valley for a lot of technologies where we have a working technology, but there's a huge investment and nobody really wants to put the money in. This is where the Rapid Innovation Fund program really steps up. It's kind of what we refer to in SBIR world as Phase 3 money. It's a collaboration between the Air Force, ISSI, Lockheed, and the AEDC team. The real payoffs of the Rapid Innovation Fund was that it allowed us to actually perform this demonstration test, the results of which showed that this was very much a practical technology.
Innovative Scientific Solutions, Inc.'s fast pressure sensitive paint technology is a perfect example of how the Small Business Innovation Research Program helps the Defense Department meet its better buying power goals of controlling costs while getting effective new technologies into the hands of U.S. warfighters.